Hi, everyone. Thanks for being here. I'm here to talk about developer tools, specifically Truffle. My name is Nick, or if you need to refer to me on the internet, you can call me @Gnidden. I work for Consensus. I lead the engineering and kind of product direction for Truffle and the Truffle suite of tools. So for those of you that are not familiar, really Truffle can be boiled down into two main tools. The Truffle suite can be boiled down into two main tools. There's Truffle and there's Ganache. Truffle is focused on the workflow of smart contract development and the different processes that a developer takes when building smart contract applications. So that includes compiling your smart contracts, running automated tests for your contracts, and we have a Solidity debugger so that you can debug your smart contracts when things go wrong. Inside Truffle and really powering it all is our blockchain simulator, Ganache, which acts like an Ethereum blockchain, but doesn't do any of the consensus management or anything like that, and instead really just focuses on the developer experience. And that includes things like giving you the ability to fork mainnet so that you can deploy your application with existing mainnet state without actually interacting with mainnet. You can do things like rewind time, unlock any account, and you can imagine how these features would play in if you're building a smart contract application and you want to make sure that it functions for all parties. So you pretend to be someone else to make sure that some particular authorization works or doesn't work. So I'm going to assume most of you are somewhat familiar, so I'll go into maybe some features that you may have missed. In Ganache, well, we've been heads down on some new stuff in Ganache, but we do have some recent features. We've fixed a number of forking bugs, so the forking functionality is a lot more reliable. You can also control the network simulation a lot better, so you can specify the chain ID. You can unlock accounts after Ganache starts. You didn't always, like that wasn't always supported. You can simulate different hard forks, which this week is pretty important. On the Truffle side, we have a lot that's been released over the last 6 to 12 months. For instance, we have our stack trace support. If you run Truffle test, this will run your automated tests. If you want to find out where something went wrong in Solidity or in JavaScript, you can pass the -- stack trace option, and you can see in the image there that you know exactly where you were when something went wrong, both the address of the contract and the line in the code. One of our, I guess, most exciting features lately is the ability to debug any verified contract from Etherscan or Sourceify. So if you send a transaction, this one, for example, is an ENS transaction. The screenshot was taken in an empty Truffle project, and I just used this -- fetch external functionality and gave it an ENS transaction, and then what Truffle does behind the scenes is it fetches the source code from Etherscan, probably, maybe Sourceify, compiles that, which has to use the right version of the Solidity compiler. So that means it probably has to download the right version of the Solidity compiler. So it downloads the compiler, compiles your contracts, gets all of the information that it needs to run the debugger, and then brings you into this debugging interface. You can see it's a command line interface for our debugger with like normal stepping controls. But yeah, stay tuned for some advancements there. In addition to debugging, we've been very focused on really making sense of Ethereum data, not just at a low level of like hex nonsense, like undecipherable hex. We want to understand that hex data in tandem with the high-level code of the developer intent. Like you're a smart contract developer, you write a smart contract, has some storage, you want to be able to see those storage values in the terms that you wrote them originally, not this like gobbledygook. So we've built Truffle Codec and a couple associated libraries like Truffle Decoder, which give a very precise machine-readable representation of these values. You can see in the image that we understand structs, for instance, and we know exactly what struct something is, or we know an array, what the items in the array are. And this can be very powerful because displaying good data and like interpreting data in this very precise, reliable way can be very challenging. Behind the scenes, we're working on keeping track of all of this information better. But when you write a smart contract, or when you're authoring a smart contract to begin with, it will go through many revisions, right? As you get things right, as you figure out the requirements, and keeping track of this without losing the historical data has been a challenge for Truffle over the years. And so we've built a new record keeping system that we call Truffle Db. And this organizes all of your information, your smart contract source code, your smart contract addresses once they're deployed, what networks they're deployed to, the compilation results, things like that. And it allows Truffle, or really anyone, users too, to query for this information using GraphQL. But the point here is, by building this new record keeping system, we're opening the door for Truffle and other tools to really have drastic improvements, right? Like suddenly the data makes sense to the computer so that it can present that data in a way that makes sense to you. So we're really excited about Truffle DB and the developments that are going forward there. I'll take a break from the slides briefly to show you kind of the capabilities of Truffle DB. And that is with, we put together this DB kit application. So I'm going to show you this DB kit application. And how it can interact with all of Truffle's other components, like the fetching external source code, and store that information in this well-organized fashion, and then query it to get additional information. So this demo, Truffle DB Kit, decodes transactions and addresses. So I have an example transaction here, and I'll show you what happens. So this got everything it needed to from Etherscan, and then it stored everything into Truffle DB. And once it's stored into Truffle DB, well, that's where this DB Kit interface comes in. You can see, well, this was this transaction. It was a function call to this contract address, and these were the arguments. And just for reference, we can look at what Etherscan shows, which is not very much. So this problem has been unsolved for a long time, and it's a very challenging problem to solve. And I think, I'm excited that Truffle is really starting to scratch the surface of solving this data representation problem. So yeah, right now, Truffle DB Kit, you can install this if you'd like, just npm install @truffle/dbkit. You can play with it, but really stay tuned for us bringing this functionality elsewhere in the application in Truffle. So we'll go back to the slides. So let's talk about some upcoming features. Well, there hasn't been a lot in Ganache because we're working on Ganache v7, which is really, it's a complete re-architecture, and we're adding things like caching. We've gotten a 200% performance increase, and that's a 200% improvement on the speed of running Truffle tests. So that's all of the overhead of Truffle, but Ganache 7 is so much faster that it makes Truffle that much faster, and that's really, really cool. Besides that, we wrote it in native Node.js TypeScript, so it's very portable. So we have it running in the browser. And since we can run Ganache in the browser, that means that we can do things like interactive docs. Oh, sorry, I didn't mean to stop that presentation. I'll show you what these interactive docs look like. And I have to warn you that even though we build blockchain simulators and Solidity debuggers, CSS is still black magic. But you can see, I'll just grab another one. We'll try ethcall as an example. So yeah, we're still, it's work in progress, right? So here's the result of this ethcall example. You can imagine what this would look like when it's done. I believe this is the only existing interactive documentation for the JSON RPC. I could be wrong, but nonetheless, hopefully this will serve as a very valuable resource to the community. So what's next? What else we got? Oh yeah, okay, here we go. Yeah, a lot of people gets scared by our command line interface for our debugger, and I don't blame people for that, right? It's intimidating, but we built Truffle Debugger as a library, which means that the command line interface is just one interface. So yeah, let's try this. Here I have the visual debugger loaded, and I have Truffle Interactive Console. So what I'm going to do is I'm going to migrate and make sure I start from scratch. And now we're going to make something happen. So this is my toy project to do a magic square. I'll explain what that is once we're in the debugger. So I deployed my magic square contract, and I'm going to now tell it to generate a magic square that's 3 by 3. So it made the transaction. Let's take a look. So here's that OXCFF, that's the right one. And we're loading the visual debugger here. And here we go. So immediately we jump in. We're interacting with the magic square contract. Yeah, just for reference, a magic square is a grid of numbers where all of the rows, columns, and diagonals add up to the same amount. So definitely we need to be spending mainnet ether on that. So that's why I wrote a smart contract for it. Yeah, you can see though our visual debugger lets you step. We can step into a function. We can look at variables like I is 0 and is 3. We can step out of a function, and we can kind of see what's going on. We can look at all these variables. Right now, we don't have a magic square yet. We're generating one. So if we just, let's just skip ahead. We're here in squarelib. Let's get back here. I'm just going to go to when we're done. So I set a breakpoint, and now I'm continuing. Magic square is not Sudoku. It's just another mathematical toy, I guess. So yeah, here we have, so I skipped, I showed you initialize, then I started stepping through it. The code's not important really, but I've skipped over to this part where we're ready to save the result. And you can see here is our magic square. Feel free to check the math. And I'm pretty sure it matches this one, just transposed 816, 357. So you can see that you can really get a sense of what your code is doing by using a debugger, a stepping debugger. So yeah, we're really excited about this. This isn't as fully featured as our command line debugger, but we're obviously very keen on adding all the features. There's feature parity across the two interfaces. So that's that. And probably nothing else here worth showing. You can reset, you can continue the basic things. This is a live demo. All right, what else we got? One more, I think. Really, all of this functionality is very exciting to us, and we're trying to figure out other ways of bringing these capabilities to the community. And turns out there's quite a lot of opportunity for that. I don't want to give away too much, but maybe I'll just drop this screenshot here briefly. Yep. Well, anyway, that's all I have for Truffle. Thank you very much for listening. I hope you're as excited as I am.
Awesome. Thank you so much, Nick. Thank you so much for everything. And also thank you for the couple sneak peeks that we saw there. There was a lot of excitement about interactive docs, as well as the other sneak peek you gave at the end there.